When using the Voltage Current Controller Module, or VCC, to demonstrate the operation of the stepper valve, one can use the two different demo closed-loop buttons on the lower right-hand side of the VCC test tab. One button is labeled Demo Closed-Loop Mode. For demonstration purposes, dialing the dither pot to its minimum setting or fully counterclockwise on the stepper 12 valve will result in the best showcasing of Demo Closed-Loop Mode. When pressing the Demo Closed-Loop Mode, the VCC initially provides an open loop control signal to place the valve at a position equivalent to a control voltage value of 5 volt, which is approximately halfway open for the stroke position. This gives the stepper a mid-starting point when showcasing the operation of closed-loop mode. The feedback voltage is set to a value of 5 volt at this time as well. After the stepper has reached a position equal to the open loop control voltage of 5 volt for approximately 5 seconds, the VCC will apply a high-level signal to the switch input of the stepper 12 controller, which will then put the device into closed-loop mode. Let's see this in operation. So we applied 5 volt to our both signals. We're going to switch to closed-loop mode. So now our control signal is increasing by 0.1 volts per second until we get to 6 volt. Our stepper is trying to open. Our feedback is now increasing, and as that difference becomes smaller, the stepper takes smaller steps to open. Both inputs will stay at 6 volt for approximately 10 seconds, at which point the control input will begin dropping by 0.1 volt. As the difference becomes larger, the stepper will then close more and more. And now our feedback signal is dropping, simulating that the system has throttled down the flow that's going through it. So what happened here? So we had the control signal increase by 0.1 volts per second until reaching a maximum control value of 6 volt. As the control grew larger than the feedback signal, the stepper was attempting to open the stepper valve, simulating the device attempting to increase the flow, which would have resulted in an increase of the feedback signal. The feedback signal also increased by 0.1 steps volts until reaching 6 volts. As the feedback signal got closer to the control voltage, the stepper opened in smaller amounts. Once the control and feedback signals were both at a value of 6 volts, the inputs were within hysteresis and the stepper stopped opening. The control and feedback signals stayed at the value of 6 volt for approximately 10 seconds, after which time the control input then started to decrease by 0.1 volt, and then we saw our feedback signal beginning to drop as well. Once our control voltage and feedback voltage got down to a value of 5 volt, the stepper valve stopped moving and the LED ring turned yellow. Modifying the speed pot or the dither pot will change how quickly the stepper valve will react to differences between the control and the feedback inputs. A lower setting of the speed pot will mean the stepper valve will open slower. A lower setting of the dither pot or the hysteresis pot will make the stepper more responsive when there is a smaller difference between the control and the feedback. A larger setting of the dither pot will mean that the stepper will not react unless there is a larger difference between the two inputs. The dither pot has a minimum setting of approximately 0.1 volt and a maximum of 1.0 volt. When the dither is set to its minimum value, this means if the control and feedback are more than 0.1 volt in different values from one another, the valve will begin to react. If the dither is set to its maximum setting of approximately 1.0 volt, the stepper will not begin to respond unless the control and feedback signals are more than 1.0 volt apart from one another.